Hi everyone, welcome back to my math channel online again today. In this video today, I would like to talk about the new topic of the pre-calculus math 12, which is the function and their operation. In the previous video, I have introduced to you about the function and their operation and what is a one-to-one function and how do we identify the relation is a function or not. So after that lesson, I get into the operation of the function. So today, this topic will talk about their operation. The lesson will not be too hard, too difficult. It's just like we add and subtract, multiply and divide algebra expression. However, we just have to pay attention a little bit into the domain if it's the rational function after we get their results. So let me get into the first question and see what we will do today. So on the board, I have the function f of x, which is equal to x squared plus 5x plus 3. So the first function is a parabola function or the quadratic function. Then I have a g of x is the linear function to x minus 1. And I have I of x equal 1 over x, which is the basic rational function, and kx equal 2 divided by x plus 2. So all of this function here, we're supposed to subtract them, multiply them, or divide them. The first question asks us to find f minus g of x, which is the same like f of x minus g of x. So let's do that. So we have f minus g of x will be equal, and this question is a will be equal, f of x is 2x squared 2x squared plus 5x plus 3 minus g of x is 2x minus 1. So I'm going to put them in bracket. And the answer will be easy, just 2x squared. Now, I'm going to do quickly 5x minus 2x. You see the like term, right? We have 5x minus 2x equal 3x plus 3x. We have 3 minus this minus, we change this minus become plus 1. And we have 3 add to 1, so become 4. So that is our answer. So the result of this two functions subtract each other. The f of x minus g of x will be a parabola. And like any parabola, the domain will be on the x will belong to the real number. So we don't have to worry about the domain very much. Now let's go to the b here. So for the b, we have g of x times k of x. So we have two functions multiplied together. So our function is gx is 2x minus 1 times with kx. And our kx is 2 divided by x plus 2. So times with 2 divided by x plus 2. Now, as a result, we always distribute to the top, right? So the bottom, the same. So we have 4x on the top minus 2, and the bottom is x plus 2. So this is the result of gk of x, two functions times together. Now, because this is the rational function, so maybe we go further a little bit by state the restriction of the denominator. So we say as long as x have to be different from -2. So we can state the domain is a set of x such that x have to be different from -2. And other than that, x belong to real number. So that's how you state the domain. Now let's do the next one, which is C here. We'll do f divided by j of x. So f of x divided by j of x. And our f of x is 2x squared plus 5x plus 3 divided by j of x. Our j of x is x squared minus 1. So we'll divide this. Now, when we have a function like this, we try to simplify the expression if we can. Now, if we cannot, then we have to leave it that the way it is. But let's see if we can factor it out and simplify it, right? So I'm going to factor this. And the way I factor, I'm going to split the first constant coefficient of the highest degree. And this I split become 2 times 1. So I put in the side word 2 times 1. And the second one is 3 times 1. So I put in the side words as well, 3 times 1. Now we'll do cross multiply. 2 times 1 is 2. 1 times 3 is 3. I test it. If I add these two numbers down here equal the midterm, then my product is okay. I will be able to circle that. So add 3, add 2 will give me plus 5. So that should be okay. So the top, when I factor, will become 2 brackets multiplied together. The first circle will go in the first bracket. The second circle will go second bracket. So I have 2x plus 3. The sign I will pick up from here, correct sign, right? And the second bracket will be x plus 1. So that's how I factor it. Down here, I also can factor because this will look like the perfect, the difference is square, right? So this is like a squared minus b squared equal a plus b times a minus b, right? That's the difference is square. So our a is x and our b is 1. So a plus b is x plus 1 times a minus b is x minus 1. Now at this point, I look at x plus 1, x plus 1, they in bracket and they look the same, so I can cancel it. So the answer for this expression will be 2x plus 3 on top, and down here will be x minus 1. Again, because this is the rational, so we should state the restriction. We will say x cannot be positive 1. That's a restriction. So we're done with A and B and C here. That's how we state the restriction. The restriction, which is the same like the domain here you state. So we're done with that. Now we're going to proceed to 2A here. So I need the board to write down. So I'm going to have to erase this border. Now, if you register to my course online, you have all of this material and you're not losing anything. So let me erase here. And by the way, if you register to my course, you will go to mathcourses-online.teachable.com. So see you there. So let me write out 2A here. So let me answer The next question for us will be 2a. So in 2a, we're going to use the same function here, right? Except we're going to use now for the 2a a little bit different, right? So for 2a, they ask you to evaluate if x equals 4. So you divide the gx, divide by fx, but also you will evaluate if the result have an x equals 4 after the operation. So let's do the operation first. So I'm going to say gx divided by f of x will be equal, our gx is 2x minus 1, divided by f of x is 2x squared plus 5x minus 3, no, plus 3. So that's the operation we do. Now, they also want us to evaluate the result as x equals 4. So at x equals 4, we will substitute this expression x equals 4 into this expression, minus 1 on top, so 2 times x, which is 2 times 4 minus 1. Down here we have 2 times x, which is 4 squared, plus 5 times x is 4, plus 3. So let's calculate this. 2 times 4 is 8, 8 minus 1 is 7. So the top we have number 7. In bottom we have 2 times 16, right? 2 times 16, which is 32. Adding with 5 times 4 is 20. Adding with 3. So the answer will be 7 over 55. 32 at 20 at 3 is 55. So that is our answer for the 2a. So we done 2a and we get the answer is 5 over 55. Now let's do the b. And the b here we have f minus k and evaluate at minus 2. Okay, so our f is, follow this, will be 2x squared plus 5x plus 3. That's for our f of x function. Minus k, our kx is 2 over x plus 2. And after we do this operation, we want to evaluate minus 2. So let's see how we can do this. Okay. Okay, so I want to know if I can factor this and we can simplify the expression a little bit, right? Now, obviously, you know that if you put minus 2 in here, this will blow up, right? You cannot do anything. But let's say if we try to simplify it and evaluate it to see if we can simplify, we can go any further. Now, if this one, I want to subtract this, I have to do common denominator, right? And on the top, I have to do common denominator as well. So I put 1 underneath, and it means the top, I have to time with this number, and the bottom, I have to time with this bracket, right? That's how I do common denominator. So this time with this. Okay, so let's see what it look like. Now, if I change this time with this, I will have 2x to power 3, right? X squared times x, 2x power 3. 2x times square times 2 is plus 4x squared. 5x times x is plus 5x squared. And 5x times 2 is plus 10x. 3 times x is plus 3x, and 3 times 2 is plus 6. So that's on the top when we multiply this bracket with this bracket. And minus 2, but all of this will get the same answer down here, x plus 2. So again, we still get stuck even though we try to simplify, because if we do common denominator, we still get, unless if we can factor out the top, we can cancel the bottom. Okay, so let me think of another way of doing this. So instead of doing common denominator, right? Let me try to see if we can okay, let's see if we can divide it. So let's just do common denominator again, sorry. So x plus 2, right? On the top, we multiply with the same bracket, right? If we do common denominator. So sorry, I'm gonna do it again, okay? So 2x times x is 2x to the power 3. 2x times 2 is plus 4x squared. Now 5x times x is plus 5x squared. And 5x times 2 is plus 10x. 3x is 3x plus 6. Now we minus 2 and all of this over x plus 2. Okay, so let's simplify this one. So this will become 2x to the power 3. 4x squared plus 5x squared is plus 9x squared. 10x plus 3x is plus 13x. And 6 minus 2 is 4, plus 4. All of this over x plus 2. Okay. So now I'm going to continue with this. So I have to erase a part of the bar so I can have room to continue with this. Okay, we want this, right? F minus k, and that's what we get. Okay, so at this moment, what we're going to do with this expression, we know that if we plug the minus 2 in here, the bottom will be blow up, and we're not allowed to have a 0 for the rational function. So what we can do is, I'm going to use long division, divide this to see if we can simplify it further. But let me think about a moment. Now, if we divide that, we get the remainder. Then if the remainder, if we still have a remainder, it means we still have to divide it by the remainder by x plus 2. And the problem will not be solved. So let me use, remember the first time we learned the polynomial function, we use a factor theorem or remainder theorem. So let me use a remainder theorem in here and find out if we got a remainder is 0. If we got remainder 0, then we don't have a problem. It means this term will cancel out and we don't have any problem, right? So let's try the remainder theorem. So the remainder theorem say that P, now if x plus 2, it means if x plus 2 is a factor of this function, then x equal minus 2. So we will try x minus 2 and see if we get any remainder, okay? So instead of use long division, we'll find the shortcut to solve the problem. So our P minus 2 will be equal, substitute here, we have 2, x will be minus 2 to the power 3 plus 9, and x squared is minus 2 squared plus 13 times minus 2 and plus 4. Okay, so let's calculate what it becomes. So 2 times with 2 to the power 3 is minus 8. 2 to the power 2 is positive 4. 4 times 9 is 36. 13 minus 2 is minus 26. And plus 4. So we have 2 times minus 8 is minus 16. Minus 16 minus 26. Add 36. Add 4. So this will give us 40, right? 36 add 4 is 40. 26 add 10. Okay, so this will give us negative, but it's not going to be equal. So this will be 42. So no. So if we add minus 42 with 40, we get minus 2 as a remainder. And it means that we still have to use minus 2 here, divide by x plus 2. And if we do 2 remainder divide by x plus 2, again, we cannot evaluate this. So I can see that our conclusion will be no. We cannot operate this. So we're going to say this operation is not valid. And our answer will be undefined because we cannot operate it, right? So not on the time on the function we supposed to subtract or adding them, and sometimes it work out, sometimes not work out. Now usually they all work out on the case, right? But maybe the author wants us to try this to make us to be aware that sometimes we cannot subtract the function like this. So that's the idea, right? If we're confident that we don't make any mistake from algebra mistake and it look like this, so that's the case. So this answer will be undefined. Okay, so let's do the next one. So we done A, the A will be able to evaluate, the B we cannot, we say undefined. So now let's do the C and hope that the C will be okay. So the B is undefined. Okay, so I'm going to erase this and we're going to do the C. We continue with the C. So in this video, I would like to show you how we operate the function, and then you will see more interesting stuff for the next video. This video is not too difficult. If you all learn up to this level, everybody know how to operate the algebra expression. But because I designed the course in the sequence at lesson, so I'm not going to omit this. I'm going to show you as well in the course, even though it's not too hard. Now we're going to use C here. So for the C, we do K minus I, and we will evaluate if x equals 7. So our Kx is what? Our Kx is 2x plus 2 minus our Ix is 1 over x. So this is the rational function. So this is just a little bit review, right? When we subtract this, we have to do common denominator. So the first fraction down here, we'll have to time with the x here to make common denominator. And the top, we have to do the same, right? Minus 1. Down here, we have to time with x plus 2. And of course, the top, we do the same, x plus 2. We time them together so that we make common denominator. So this will result in 2 times x is 2x minus x minus 2 right? We subtract on top. And down here, we have the same x times x is x squared. X times 2 is plus 2x. So now we simplify further. 2x minus x will be just 1x and minus 2. And down here, we have x squared plus 2x. Now substitute the x by 7 to evaluate. We have 7 minus 2 on top. And down here we have 7 squared is 49 plus 2 times 7. 2 times 7 is 14. So 7 minus 2 is 5. And down here we have 9 and 4, 13. 63. So our answer will be 5 over 63. So yes, we can evaluate this. So that's how we do all of this. Okay, so now let me go to the last question with you, which is number 3 here. So we're done with all of this. I'm going to have to erase this, and I hope you can follow me, right? I do a little bit quick today, right? Because this is not too difficult. Okay, so for the question 3, it asks us to do, given fx is 2x plus 1, and Lx is x squared minus 1, we're going to find f divided by L. So the function fx here will divide by Lx, subtract with the function L of x divided by f of x. So upside down, right? So fx is 2x plus 1 divided by Lx is x squared minus 1. So that's the first operation, right? Find f divided by Lx. The second operation is L of x, which is x squared minus 1 divided by f of x is 2x plus 1. Now at this point, if we just leave it like this, it means we're not trying to figure out anything. We just put in the expression and that's how it looks like. So let's do a little bit about that to see if we can simplify anything further, right? So again, this is the subtract fraction, rational fraction. So to subtract rational fraction, you have to have a common denominator, just like we did in elementary. So it means this denominator we have to time with this denominator, and this denominator have to time with this. So for the first fraction, we have to time this one with this one. And on the top, we have to do the same. It means this portion on the top here have to time with this one, as well as down here have to time with this one to get the common denominator. Now, fortunately, 2x plus 1 the same like 2x plus 1. So to multiply them, instead of expand, I'm going to just join it like this to make it easy, right? Because 2x plus 1 times 2x plus 1 is the power 2 of this bracket. So that's the left function. Now, the second function, this term will, this denominator have to time with this one, which is the top. We have to do the same, but the top is the same like this one. So again, I'm going to join this, x squared minus 1 to the power 2. And down here will be x squared minus 1 times with 2x plus 1. So that's how we operate the subtract fraction. So this times this equal 2x plus 1 power 2. Subtract this times this equal x squared minus 1 to power 2. Join the two common denominator, multiply together underneath one fraction. That's how we join them. So let's see. Now at this point, because they are subtract, so we're not going to be able to cancel anything. So let's just expand this one, and I'm going to use a formula to expand it to make it quick. So 2x squared will become 4x squared plus 2 times a times b will be 2 times a times b is 2 times 2 is 4. That's 4x plus 1. So that's the first bracket. And the second bracket will be x to the power 4 minus 2x squared plus 1. And all of this will be x squared minus 1 times with 2x plus 1. Now let's simplify the top a little bit. The top will be minus x to the power 4. This number go first. I'm going to put the power highest power first, right? Then 4x squared. Now, because this negative, we change this become positive, right? So we have positive 2x squared add to 4x squared, like term will become plus 6x squared. Now the 4x here will be just stay at 4x because that is the x squared. Yeah. So just say plus 4x. Now the 1 here is positive, but we have negative. We change this become negative. So this 1 will cancel with this 1. 1 positive, 1 negative, gone. So that's on the top. And down here we have x squared minus 1 times with 2x plus 1. Now at this point, I don't think we can factor out. We only can factor out the x, but how it's going to work if we just factor out the x. So we have x3. No, so I think this is the answer. Okay, because that's the final answer. However, we're going to talk about the restriction to domain, right? So x squared minus 1 cannot be 0, which is x squared cannot be moved over, cannot be 1, which is x cannot be positive 1 and negative 1. The second bracket, 2x plus 1 cannot be 0. So 2x cannot be minus 1. And x divide both sides by 2, x cannot be minus 1/2. So this is about the domain of the results after we find out. So I hope you enjoyed this video. And in the next video, I will talk about the composite function. So stay tuned for our next video. And bye for now.